All right, let's go ahead and kick things off. So, thank you everyone so much for tuning in today for our webinar on electronic designs with analog devices and Aero Electronics. I'm Brittany Nelson, Partnerships Manager at Indiegogo, and here with me today is Keaton Anderson, Engineering Manager at Aero. And Analog Devices is the official semiconductor technology provider of the Aero certification program, enabling entrepreneurs to interpret the world around them with unmatched technologies that sense, measure, and connect. Just a quick note on the webinar, if you have any questions throughout, please use that Q&A button at the bottom and we will try to address all of the questions at the end. All right, without further ado, Keaton, why don't we go ahead and get started?
Thanks, Brittany. Hi, everyone. My name is Keaton Anderson. I am an engineering manager here at Aero Electronics, and I'm going to be going through today a little bit about how to kind of accelerate some of your hardware electronics designs, hopefully be able to help you kind of jumpstart them and move them forward a little quicker. They can be a little tricky sometimes. So without further ado, let's jump right in. So the overview of what I'm going to cover today is I'm going to go through the overview of the design process. What's that look like? What goes into a development cycle? Then I'm going to do a little bit of that jump starting your design. So talking about what are some things that are pitfalls, where are some hangups, and how can analog devices help in this area? And the reason that I kind of want to go through it is they have such a great ecosystem that's built out for reference design, software, all the different things you're going to need to move your design along. So I'm going to highlight a little bit of those when we go through. And then last but not least, we're going to talk a little bit about the Aero certification program. So this is our partnership with Indiegogo, trying to help entrepreneurs like you be able to get your designs off the ground faster, being able to help and answer questions. And it's an interesting time in the electronics market landscape. So hopefully now more than ever, we can be helpful and kind of provide some value for your design. So let's take a look a little bit at that design cycle overview. And I have this kind of timeline that I've put together. And when I look at it, this is somewhat just my rough estimates. I'm not saying this is standard for every design. We have a lot of customers that we work with at Aero that have different design lead cycles, different timings they work with. So an example might be if we're working with a military customer or an aerospace or something, their design cycles might take 3 years as compared to some of what I'm listing on the timeline here. So if you're sitting there like, this isn't exactly what I think, this is kind of just a rough outline to give you an overview if you've never seen how that timeline looks. So the first thing you're going to do is you're going to go through that ideation phase. And this is typically your requirements gathering. This is where you're going to say, what is the different pieces that need to go into my design? Oftentimes, this will be sort of a MVP discussion, or if you have a base idea, typically you can kind of use that as a kicking off point. And from there, you're going to move into that initial design. So that ideation can potentially take 1 to 2 weeks. If you've been thinking about your idea for a long time, that could be a year or two. You know, you may have thought of it for a while, but if you're doing that kind of initial requirements gathering, I would bucket that you have at least a couple weeks to walk through what are the different MVP requirements we're going to need to flush out before we're ready to go to market. That next piece then is that initial design, and I put 2 weeks to a month. If you've not done this before, that potentially again can take a little longer, but this is supposed to be that proof of concept stage, right? So the whole idea being here, can we even do what we think we're going to do? If I want to make a sailboat that it can completely go invisible, what's that technology look like, and how would I even go about doing so? And then maybe I would do it on a smaller concept. Can I do it on a miniature toy boat or something like that? Whole idea being that you should be able to get your idea up and going so that you could say, yes, this is scalable. This is something that I can produce. That next piece there is then that prototyping stage. So I've said 1 to 2 months. Again, this could take potentially longer. The whole idea here is taking that original proof of concept and moving it into more of an official design. And what you want to look at there is typically you're going to have some boards that are kind of duct taped together in a theory kind of idea with your proof of concept. Your prototype needs to start to head a little bit more in that direction of being closer to done. You should have a rough idea of how big it's going to be. So for example, if I'm wanting to do something IoT and I need to place it inside of a device, is it small enough that it can be able to fit in there? Is it going to be able to draw enough power? Am I able to do this? What batteries exist? Those kind of things. And really at the end of that, you should have a pretty fleshed out design at that point. The next thing there is then that first production. So that's that 2 to 3 month step. What this is going to be is doing that low volume production level of these boards. So it's potentially 1 to 10. If you're a larger company, this is typically a little bit of a more volume. They're potentially at 100 to 1,000. Just trying to get through and make sure, hey, let's produce it and let's start testing on these. And then you'll see some revisions that go through there. And that's why that last step of that mass production, there's both a time in procuring the parts, as well as there's a time and then being able to deliver upon those. And that's really one of the areas that we see the largest amount of time betweens, right? So that mass production, if there's lead times on the part, you may have to take a while to be able to source all of it. And then as well, you're going to have to be able to make sure that you've done enough revisions that your software and your hardware are in the place that you want it to be. Okay, so let's talk a little bit about the pitfalls in design. What does this look like? I've listed that there's some things with development boards, and then I'm going to talk a little bit, I've called it DIY, but I want to talk a little bit about why that could potentially be challenging if you're trying to do development on your own. So let's talk a little bit about development boards. And the reason that this is so critical is that I see a lot of this when we're working with customers who are coming through the Aero certification program. So that whole thing that I just made a lead up of, hey, you need to be able to do a rough proof of concept, you need to be able to flush out your design. A lot of times, the easiest way to do that is you purchase a Raspberry Pi and you start your development on there. You boot it up, you have, you're working on it as an OS, and you're able to just start to flush out what that looks like. The challenge that really we've run into a lot of times is we have customers who come to us that they've built their whole design, they're feeling really confident about it. They say, great, I'd like to buy 10,000 of these. And it's really hard to source 10,000 of them. They're not as intended to be able to take to large production. And you look at scaling that into hundreds of thousands and millions, those are really challenging at that point. I mean, you're really running into volume limits at that. So that's one piece of what we look at there. The second one there is then, so they say, okay, great. I'd like to take this design and move it to another board. And in many circumstances, the code that's built there for Raspberry Pi, it's within potentially a noob's operating system or using some sort of hat or something like that. That code is typically not one-to-one. You can't just lift it from the operating system and plug it into a new system. There are exceptions, there are workarounds, but it's not really very easy to take it from one place and go to the other. And then that last thing is those chips are typically proprietary. So this BCM 2711, which is on a Raspberry Pi, it's that big processor in the middle from Broadcom. They're typically really hard for an average user to be able to jump in and say, I'd like to try to buy these because I'm going to build my own board, or I'd like to build my own Pi. They're really hard to be able to get at volume, and oftentimes it's not a telling of the supplier or anything like that. Moreover, they're just very hard to source from that perspective. So development boards are really good for being able to say, yes, I can make this happen, but they may be really challenging to then move your design forward to more of a production state long term. Just something to keep in mind. That other piece that I wanted to talk about is this DIY. And it's not to say that this is something that you should be wanting to do some of the development yourself, but I want to talk a little bit about what are some of the challenges with that. So for example, if you look at your custom development in terms of time, right, you're going to be able to set up your own board. You're going to have to go through, but in many circumstances, you're looking at, I have to try to hire someone who's a different specialty. So unless you're an expert on power electronics and RF and memory, timing, all those kind of things, you may run into some challenges, and there's a learning curve to each of those, right? So you add time in every single step along your design. It's also very expensive in terms of being able to then hire people to fill those roles if you potentially do. The second piece of that is then going to be talking a little bit about reference designs, and I'll talk about that here in a second. But in many circumstances, these designs have been done before. And if you have something that's like very high-end proprietary, it's different, that may not necessarily apply to you, that may not exist. But there are certain pieces of the designs that have existed in market today. A good example being, if you were to try to integrate Bluetooth into your design, that's been done a lot, right? Bluetooth has been around for a while. It's a very adopted standard. There are ready chips available for that standard, as well as code to be able to port and add that to your design. You may not need to do that from the ground up. You may be able to just take a reference design that's adding Bluetooth or a module or something like that, bring it into your design, and now that's one piece you don't have to deal with as you're moving forward. So my advice in this section, and we've told people this before, is don't rebuild the wheel where you don't have to, right? If you can be able to take and utilize reference designs, utilize some of the kits that are available out there, um, don't worry as much about having to reinvent that. Instead, focus on the things that are your strengths. What is that piece of your product that is going to make you valuable? Why are you niche? What is going to make you something that customers want to see you in the market? What's that thing your backers are going to want to see? Those are all questions that you should answer in that requirements gathering step, that are going to lead you to success. And it should be less around, hey, we need to figure out how to implement Bluetooth, and more around, hey, we know how to do that. There's a design out there that does it, but we really want to focus on this thing that's going to sell our product long term. Okay, I want to talk a little bit about circuits from the lab. And so this is going to be kind of the majority of where I'm going to spend some time. I'm going to go through some case studies and some examples of how this works. Our partner for this is Analog Devices. We'd mentioned them at the start. They're a company I'm very fond of. I've had a lot of chance to work with these guys, and I can tell you from a resources and availability perspective, it's the way that I would go. If I were starting a new design today, this is probably how I would go about doing it. And so I'm going to talk a little bit about what are some of the evaluation kits that exist, what are some of the reference designs, things like code, symbols, footprints, all the stuff that you're going to need to kind of take your design from just that idea, and we're going to get it ramped up as quickly as possible. So let's talk a little bit about what these are. So I took a circuit note from one of their reference examples here to showcase a little bit of a design. So this is for, it's doing smoke testing for a fire detector in the ceiling. I'm blanking right now, smoke alarm. And so what this is going to be looking at is, you can see there are different aspects of this design that are built in there, right? So you're going to have that micro SD card, which is going to be able to pull in that data and store that data. You're using multiple different interfaces to communicate. It's got an integrated optical module. You have some integrated LEDs there, some heating resistors, an alarm indicator. All those pieces are built into this one reference circuit, right? And so this essentially says that if you take these pieces and combine them in the way that we've said that you should, you're going to come away with a pretty close to complete design. This one in particular also is can get very high end, because you do have that option there with that fire detection algorithm to be able to take a ton of testing that's already been done and load it into your design. So now you're not necessarily having to go do field testing on smoke, or something like that. That has already been created from that algorithm. So I'm going to talk about a couple different examples, but just so you have a framework of what this looks like, this is kind of an idea of the reference portion of it. I'm going to talk a little bit more about the evaluation piece now. But first, I want to talk about the smoke detection, about where's the value from it. So let's walk through this typical timeline again. So I'm building this smoke detector. It's an IoT smoke detector. I'd like to be able to have it send alerts to someone's phone. I want to be able to, deploy emergency services to be able to check on my house, so on and so forth. So let's walk through this. I have this idea. And then I'm going to go about brainstorming. So there's a couple things I need it to be able to communicate wirelessly. I'm going to have, at a minimum, there's going to be some level of smoke detection, optical detection. I need to be able to see, hey, that exists. I probably need to have some way of being able to transmit that signal. I need to be able to have power for the device. Where's that power coming from? I probably need some sort of battery backup. These are the things you should be looking at when you're doing that brainstorming. And out of that, you're going to do some research to say what exists in market already, what is some of the technology I might need to use, and that'll then drive kind of that proof of concept, right? In this circumstance, you may be able to say, hey, I could go to this next step of this requirements gathering first and say, I'd rather just try to put together some of it. But the proof of concept, the reason I've put it here is because in this circumstance, you may say, can I even do this? Is this something that can even work from a technology perspective, before I'm building that requirements? I've already kind of given you the answer that there's a reference design out there, so that's spoilers, but this might be something that you're kind of working through and saying, if you're looking at your own design, can I even do this? The next piece is then going through that part selection. We typically refer to this as hero part selection. You're looking for the key aspects of your design that you're going to need to be able to actually get it to function. So that's going to include your microcontrollers, that's going to include sensing, that's going to include all the pieces, power that go into building that design. And you'll want to pick certain parts because they will define the rest of what will go around there. The next piece is then going to be that software development. So you got to write that algorithm. You got to be able to determine how am I getting this to communicate? What happens when this triggers that event? So on and so forth. Then we'll do some level of that first production, or we'll have a unit come out. And then finally, we're in mass production. Okay. So as I talked about before, this could take a year, 2 years, so on and so forth. So let's take a theoretical example of what this would look like if I'm doing it with a circuit from the lab. So I have this idea, still gonna have to do that. I'm still brainstorming. I've gone to research, but this time instead on my research, I found, hey, there's something that already exists in market. So now I have something that kind of is already demonstrating the proof of concept. Potentially, it's already helped me define what are my MVP requirements, what I need to do, and the parts are already defined in there, right? So that next piece that I'm going into, oh, and the software is also included. Typically, you'll have that as part of the setup code and such is included in that design. So now I've jumped to, I'm potentially taking all those, flattening those dead boards into my own board, and I'm looking at that first production. So I've taken a big leap going from that research step all the way potentially to a working product that I can then take for first production. And then obviously we're looking at mass production. So just to talk a little bit more about why you might want to use these. So there's a large range of applications. You have sensing, power, communication. This slide could just be bullets on that. And there's a ton of different applications that you can use here. As I mentioned, it's going to include that reference circuits. So schematics, Gerbers, which is the physical layout of that design, as well as the bill of materials. If there's reference code that's there, which can be dropped from one device in the family to another, that's very easy to do. And then simulation files, RF, LT-SPICE, all of those are included in there. As well, there are additional resources for you. So you have circuit notes, you have technical articles going through these. These all have quick start videos, things like that. And then additionally, there are projects available in the engineer zone. And I'm gonna highlight a little bit of some of the resources available. I'll give you kind of links a little bit later on, but I'm going to jump into an example case so we can look at what does this actually look like in practice. So the first thing is, let's take a look at a water quality example. And we had a customer that came through that was actually doing this. So they were going on a design. They had a part that went obsolete on them. Nowadays, that is probably very easily where the part could be not available in stock for a while, and potentially there's an issue from sourcing it. So there was no stock there's no stock available, and there was no drop-in replacement. So it was not something that they could very easily shift from. So what they decided to do was they utilized a water quality reference design. And so it was the CN 0349. And essentially what they did was they took that circuit and they jumped in immediately with that, including the reference code for it. And what we saw was that redesign was completed extremely quickly. Instead of having to go and redevelop everything that they had done, they had a new design that they could be able to leverage, and then they just had to be able to communicate to the system they had already built. And so they completed a new hardware system. They were able to do the software migration, and then the new solution that they had built was actually a better solution in that it had an additional amount of bits that they could be able to store that data in. It was more precise. They were able to see more data, and they were able to include additional features in that first design that they thought they were going to have to include in a later design. So all in all, a win in that regard. A little bit of a scramble situation, a fire drill, but it was something that was a really cool use case to be able to see. And this was when we started to develop, how do we think that we could move forward with more? And ADI started to do even more work and development on some of these designs. Another example here is a greenhouse example. So we built one of these to kind of showcase a little bit of what some of that stack would look like. So there's a bunch of different boards there. If you're building your own design, it's not going to be this giant brick. This is just a way of being able to showcase that you can do this testing and development and such as you're building your own board. But it utilized a couple of different reference boards here. So we had a light recognition board, being able to tell, color and intensity. We had a soil, moisture, and pH board, that IoT MCU, so that microcontroller running all of this, and then an LED light source. And what was really cool about it was you could take this design, potentially if you had I'm not very good at plants, but in theory, you could grow a plant using this. So you could use the probe to be able to determine light, water, pH for it. You could build a whole ecosystem. And I have a brother-in-law of mine that really wants an avocado tree. So I've been tempted to break this back out and see if we could do one in my backyard. But as it turns out, that doesn't work as well in Colorado. So we'll see what happens. But the whole idea being that you have multiple different designs that you could bring in here, and you could potentially build out a whole reference with multiple different sensors, having not necessarily needed to build out each of these individual use cases. You could use the technology, use the communication profiles, and flatten this into one board that's just your all around weather station greenhouse kind of tracking system. And then this last one was, I made a case study of a bike helmet, and I just wanted to talk a little bit about theory because I had done a little bit about water on both of these. So this would be an idea of, let's say, e-bikes are something that we see a lot of. They're really popular. They're something that is continuing to grow in popularity. So let's pretend that for a second we had a helmet that we were designing. We wanted to track acceleration, temperature, humidity. I'm going out for a ride. I want to be able to see what's the weather look like around me, what's the humidity look like. Potentially, if my user's gone off the rails and they're going too fast, do I want to try to help assist in braking? There's all different things, but the piece I wanted to highlight here was that we had a different protocol entirely. So on that last design, I was talking a lot about Arduino. There are Raspberry Pi based options from that same form factor for these designs. This one's going to be based on that PMOD form factor. So we have the evaluation looking at acceleration. We have that same one for humidity and temperature. And so if you wanted to plug that into the design, now you're potentially leveraging an area where you have utilized a PMOD or an Arduino from that perspective. And now you can be able to take that same design and utilize the technology that's built on top of it instead of having to switch up from what you're doing. ADI does provide some of their MCU platforms to be able to do the processing. So if I were building from scratch, I would probably start there. But if you had already leveraged this for your proof of concept, say like an Arduino or Raspberry Pi, it could be another way to be able to jump in. And there is a list and a guide that will kind of walk through that a little bit. So how do you find that right platform? You're doing that research step. What does that look like? So I wanted to highlight this. It's on analog.com, you have their design center with reference designs, and this is the circuits from the lab portion. This is going to be an area where you can be able to go in and search what are the different reference I'm looking for. You can search by keywords. So if I want to do something solar based, I could potentially do that, energy harvesting, so on and so forth. That's one of the ways that you can be able to reference some of the platforms. I will include a guide. I think it's right here. So what are some of the different resources you have? If you go to aero.com, we have our page for analog devices. This has a list of reference design, sensors, technology, platforms. It's pretty robust. We've gone through and kind of defined a lot of what might be useful for your perspective, for people coming through who are focused on the, excuse me, who are focused on doing development of their own projects or potentially working from kind of that Indiegogo mind of space, people who are doing the entrepreneurs and development space. Again, I referenced that analog.com design center reference design. So this is going to be an area to be able to locate some of what has been done already. And then that last one there on the far right is this solutions for rapid prototyping. And we've worked a lot with analog devices in terms of they see the need for this in the broad market space. So they continue to update this guide. And so it's something that they have a list out there. As you can see, this one focuses just on Arduino shields. Later on down the guide, it talks about Raspberry Pi, PMOD, there's FMC connectors for FPGAs. Again, this includes the software, the hardware recommendations, the physical layout files, things like that that you would be able to use for your design. All of those are included in there. So that is a potentially very useful brochure and something that I would definitely recommend if you're going to be going and checking it out. So I'm going to let it sit for 1, 2, 3. Okay, I'm on to the last slides here. So The last thing I want to talk a bit is about the Aero certification program. So this is something that we've been working with Indiegogo for a while. And the focus of this program is to really try to help engineers move their design through that ideation all the way through production. So I gave the webinar version of this today, kind of going through a little bit of some of what I would do. But if you want a little bit more of that one-on-one help, if you think, hey, I could really use some feedback on this particular product I'm working on, some ideas, or what are parts that exist out there, what reference designs, those are the kind of things that we help entrepreneurs with on a daily basis. And so the whole idea of the program is that Aero wants to kind of be there as your technology partner along the way as you're going through design. There's no cost for the program. Essentially, the whole idea there is we want you to think of us when you go to eventually purchase your electronic components. We want to be a part of that journey, and we want to help you kind of actually have success. If you don't have success, we're not going to have success. So we want to be a part of that from that perspective. So as we kind of walk through here, if you're in the ideation step, prototyping, product launch, full product, even if you're going through those iterations or end of life, we want to jump in and be a part of that. And so we've really excited. We've been doing this with Indiegogo for a very long time. And what we've seen is that projects that go through this process and get that Aero certified technology, they tend to raise 87% more funds than campaigns that do not, and they're 4 times more likely to reach their goals. So again, this is something we're really proud of, and we hope that people will really want to take advantage of that. Just to highlight a few more things that you can look at here. So some of the benefits of the Aero certified technology badge and going through the program, you can get up to $1,000 off of Aero components and services. There's potential to be featured in our newsletter and do promotions that way. And then additionally, you'll get a chance to talk with some of the engineers that I get to work with on a regular basis. We'll go through engineering, supply chain, logistics, all the different development needs as you're kind of working through your design. And then finally, last but not least, you do have that badge for your Indiegogo campaign. And again, we've mentioned that it helps increase backer trust, and they've seen it. So with that, I am going to turn it back over to Brittany for any questions.
Yeah, thank you so much, Keaton. All right, we've got a couple of questions in the Q&A at the bottom. If you have any others, please add them now. And then we also received a few questions prior to the webinar starting.
Perfect.
So the first one here, kind of related to the Aero certification program and all the great work that you guys do. They're asking about pricing. So when you're consulting with the Aero team, how does pricing work? How are you guys able to help them with that?
Yeah, absolutely. So frequently what will happen in a design cycle, if you're looking at pricing, is if you have a target budget that you need to set at the start, we'll work with you to kind of go through what are some of the key components that you're going to be looking at. What is the cost of those? Is there a way to be able to cost down these? Typically, what you tend to see in a development cycle is someone will go through, they'll design their first iteration, and then they'll say, this is a $30 bomb, it actually needs to be 20 or 30 or 25 or something like that. And that's when we typically look at those opportunities to suggest parts of what are things that are going to potentially help you move that cost down over time. There is options to also look at when you're doing volume pricing that potentially, when we're looking at that large scale sourcing, we can give you an idea of what it costs at one component, what it costs at 100 components, what it costs at 10,000 components, and you'll see kind of the breakdowns in there. So those are areas that we can be able to help with in terms of just showcasing some of it. It is something that I will recognize that part prices have gone up a little bit. So if cost is an issue, that's definitely something that I would work with your distributor to try to see what is in stock, what exists, and where can be able to try to pull some cost out. Are there options that we can be able to work with and alternatives?
Awesome, awesome. And then this one might be better as a one-on-one question, but just high level. Do you guys work with components for like genetics or biotech industry, like synthetic biology type of things?
So we do. We have our customer base from Aero is pretty vast. I mean, we have like I mentioned earlier, we do military. We also do medical. Obviously, the trick in medical designs is there's a lot that goes into the certifications in that perspective. So we've done previous webinars on certifications and on medical. I won't necessarily need to go through all of it, but we do work with those customers. It is something that frequently we'll have to go through and say, have you done these? Do you have the classification of your medical device? Do you know what is going to be required for if you're wanting to go with like embedding a medical device? There's a ton of standards around that, and expectations in terms of what can even be exposed. Like if you have something that's transmitting next to a user's head, there's a whole different piece for that. And so um, that is probably something that's better for a one-on-one conversation, but it is customers that we work with. We do have customers that do stuff in that kind of medical space.
Awesome, awesome. And then there's a question here about who can consult with Aero. They're concerned that they're Canadian and their team is international. I believe the answer to that is Aero will work with anyone. It doesn't matter where you're located. They have
Yep.
offices all over the world.
Yeah, and we do have teams in different regions. So we have members on our team that work in Europe and in Asia as well. So if say timing's a concern, I obviously I'm states based, but if timing was a concern from that perspective, we do have different languages and different time zones available.
Awesome, awesome. Okay, we've got a question here. Is it recommendable to design a PCB with a startup product or go with standard components such as the Arduino product range?
So I talked a little bit about this in the design. The key thing that I would highlight here is just making sure that you can source it, right? So if you are going to start with that Arduino form factor, make sure you understand the reference piece of that. One of the challenges that we ran into recently is I had a customer of mine that was looking to source one of the ST microchips that was a part of that design, and it was just out of stock entirely until 2023. I mean, there was absolutely nothing to be done about it. And so one thing I would recommend is if you're going to move forward with that Arduino form factor, make sure that you can be able to source it, as I kind of highlighted on that Raspberry Pi earlier. If you're starting with, say, a strategic supplier, that's obviously a key factor there as well, but at least you have an ecosystem that if you need to pivot to another piece within that same family because there's a stock out in that particular component, they frequently will have alternatives that are just slightly different. Maybe it's a little bit more processing power or something like that. So your code's not completely dead at that point, right? Like you have a way to be able to very easily transfer from one member to the other member of the family. And that's kind of why I was highlighting a little bit of some of what we're doing with the ADI reference designs. They have different options, and it's very easy to transfer that code from one platform to another.
Awesome, awesome. Yeah, let's touch on kind of the shortages in the market right now. Like how is that impacting new electronic designs?
Yeah, so this is something we get a lot nowadays. So shortage market, just so if you're unaware of it, essentially what we had seen kind of coming into the pandemic and definitely coming out of the pandemic is because of the large shutdowns of factories and the diminishing availability of resources. Electronic components as a whole are a lot harder to find than before. So I had just referenced a customer of mine. They were looking for a certain part, and we had to come back and say, hey, they're not going to be building more of those, and we won't have them until 2023. So just as a general note to be aware of with kind of keeping shortages in mind, there are things like our bill of materials tool that we have available that can help address some of those concerns. So if you upload your BOM, we can give you an idea of, are these parts in stock, number one. This is another area that the certification program does help with. So if you come in and you say, hey, I'm not seeing this anywhere in market, do you have an alternative? That's something we can very easily help with. We can go through and take a look, does something else exist in market? What's available? And we've had a lot of customers that have said to us, hey, I used to source this from here. Do you have something in the comparable spectrum so we can be able to keep going? We can't produce at the moment. We're stock out, we're lying down. How do we be able to do that? So this is an area that I think we can still, this is an area I would say as a whole that Aero provides a large amount of value because we have such a broad line card, and we are global, that we do have a lot of different options. So if you were sitting there saying, hey, I'm a customer, I have a new design, I'm running into shortages, or I'm trying to plan a new design, I don't want to run into shortages, I want to be able to get it out end of this year, early next year, stuff like that. I would definitely recommend looking at the program and getting in touch with us. That this is an area that we can potentially be able to provide some real value for you.
Awesome, awesome. Okay, here's a question. In case of malfunctioning components, is it advisable to seal the electronics compartment for warranty but then risk higher shipping costs and labor to replace parts, or leave it open to allow the customer to replace individual components?
Yeah, this is super interesting, right? This is one of those things that is probably going to also get defined a little bit by some of the right to repair laws and such that are going through. But in general, let's talk in general. There's a couple things that you could be able to do here. One, I would typically tend to leave it somewhat able to be opened and repaired. What that's going to do is it's going to encourage, if you have customers who know they can make repairs, that is a plus from that side. You already have a way for them to be able to do so. Even things like when I look at large scale electronics, your things like your PS5s, your Xboxes and stuff, most of those times those can be opened and people can replace things. They may not always know what they're doing, but that is the case. So the benefit being that that could potentially be an option for customer satisfaction. The caveat I would put there would be I would have some way of being able to determine that someone has tampered with it, right? So that you can still to keep your warranty in mind. If someone did go in and try to make repairs and did not do a good job and they blew the whole thing up and now it's, pretty much having to replace the whole device, you don't want to be on the hook for that. It's a lot easier for potentially your technicians to take it, repair a piece in it, and send it back out to the customer than having to deal with doing an entire rebuild entirely. So I would state that I typically think your best option here would be to still leave it open, still leave it away for it to be accessible, but have some way of being able to determine, did the user actually take the time to open this up? This is really frequent in devices. And then they also do this with like in cell phones, they used to have like water detection to be able to see like, did you get it wet kind of idea. There are very easy and cheap solutions to be able to do this. Some as easy as like tape that will definitely leave residue or such. But I would make it such that you can get inside very easily, but you can see if the user's done so.
Good advice. Going back, I think kind of to kind of the benefits of the Aero certification program a little bit. There's a question here. Do you have a network of recommended service providers such as PCB editing and manufacturing services?
Definitely. Yeah. So there's a couple of different pieces of this. There's just kind of the obvious of like software and such. Some of that will become preferential and some of it will be based on your CAD. So if you've decided to go with a particular CAD provider, there may be certain softwares that you choose to use. In terms of the service providers from, say, more of a services end, manufacturing and such, frequently what I will do if I'm talking with a customer here is take a look at location. So there are options to be able to go overseas. That has its pros and cons of potentially cheaper, but also not frequently you're going to have a lot of boards that come back that don't work if you get your PCBs done over there. So there's some kind of ways, pros and cons in terms of how you would be able to go about it. What my recommendation would be something we'd be happy to discuss. Otherwise, if you're kind of just like, hey, I need to be able to determine this, take a look in your area and see if there are some companies that are EMS. You potentially can find EMS companies online. I won't mention a ton. I mean, you have a couple different people like your macrofabs or circuit hubs. There's a wide variety of these guys that do this. Not a sponsor. I'm just going to go ahead and put that there. I've had a chance to work, and they have really cool software that be able to work with them. So they have capabilities where you could be able to go in and try their demo and see how they flush it out. There are a lot of companies that do that, though. So I would research your EMS companies to be able to see where's the pricing on it, and then I would also look for a local CM potentially nearby that you could be able to visit or quote a design there to see what that looks like. We have some guys that are 10 minutes up the road that I can be able to drive out to. It comes in big when you're trying to do that process that you don't have to be flying back and forth, especially with all the travel restrictions right now. If you were going to try to develop a board today, I would really want my contract manufacturer to be local if possible.
Yeah, just a quick follow up on that, really quick, Keaton. People are asking for definitions. When you say EMS and CN,
Sorry.
what are you referring to?
So electronic manufacturing service, they're going to be people who do CM is contract manufacturer. They are someone who will do the build portion, the PCB and placement, PCBA portion of your design for a cost. So they will build the board and they will populate the components for you and they'll return your design back pretty much done. What an EMS is it's the online version of this that's been starting to develop, where you have companies who are going to let you do a lot of that development online, and then they'll service and ship those parts to you from it. So typically, the way it used to be, you'd call a CM, you go drive out there, you'd have your designs, you'd talk to them, that kind of thing. This is sort of the rising age of technology where you can be able to do a lot of this and self-service your design in terms of BOM layout, make sure that a lot of it's done correctly, and then they'll just ship you the boards. And so both are still good. A lot of times your CMs have now become a little bit more of these EMS companies where they can do a lot of it online, but they're both just options to keep in mind. Essentially, the whole point of it being these are guys who will build the printed circuit board, assemble it with all the components, and give you that finished product.
Awesome. Question here for the Aero certification program. Again, there's someone that has an idea for a tech product, but they don't necessarily have a lot of tech experience. Would they be a good fit for the Aero certification program?
Yeah, and that's an area that we'd be happy to talk with them about. This is one of those things where when you come into the program, one of the feedback points I might give you is if you don't have a lot of tech experience, let's start with one of these reference boards. One of the benefits of the circuits from the lab is they have a YouTube channel which showcases how do you take it out of the box, how do you plug things in, how do you go through putting the code on the board. There's a lot of resources that are available for you so that you potentially have success. And I would say now more than ever, there's a good route for you to be able to go. So if you do come into the program, we'll talk to you a little bit about your design. You'll work with kind of from a consultation perspective and talk with one of the engineers. And then, that's when we kind of potentially point you in the right direction to say, hey, here's how I would go about it. Here's some areas I would do some research on to get your design off the ground faster.
Awesome. Awesome. Okay, so what changes in technology will impact how products are developed in the upcoming years? Like, what can we expect in the next few years, do you think?
Yeah. Um, we actually were just getting ready to put an article out with I believe we'd partnered for an article on this, but I'll talk a little bit about it. So 3D printing in an example is kind of an area that's rapidly developing, and you're starting to see more options come up in that space. So I just talked about going and getting your boards produced or shipped or something. The concept of being able to print a design and do it at home may mean that you have a way of doing a lot more of this development very rapidly and very locally, potentially even in your house kind of idea. So that's one area that as we're seeing that technology change a bit. So it used to be you had kind of just rigid boards, you have now more flexible boards, and then you're potentially looking at 3D printed as compared to large tens of $1,000s of machines to be able to do it. That is some of the thing that's going to be driving where we're going. The other piece that I will add here is that sensing as a whole is starting to become just standard in your designs. And what you're able to sense is becoming more and more available than it was before. So it used to be something where it'd be like, great, I got a temperature sensor. That's like the best I can do, right? And now it's like, if you want to know the saltiness of your sweat or something, there's a way to sense it. Like there's so many things that can be determined. And it's at the point where the expectation of the customer nowadays is that they are able to communicate everything to their phone. There should be a way to connect it to my apps. I can share it on social media. That is going to drive the way that technology is developed a lot more around a user base that has expected technology needs. And now it's going to be a niche development of what is that thing that makes you different as you kind of technology becomes very commodity and expected, even in things that you weren't expecting before. Like, why does my fridge have a refrigerator have like a screen on it or something? As that becomes more expected, I think from a 3D, from a driving perspective, you'll see one, that there's so much sensing out there and it's going to be something that is going to be expected of your designs. And two, you're going to start to see potentially more of this being able to be done in like a localized home area.
Awesome. Well, thank you, everyone. Wait, one last question here. Is there simulation software for Aero Components or API or some module in simulation softwares? I'm not sure if you're familiar with that, Keaton.
Yeah. So typically because Aero covers so many people on our line cards, frequently what you'll see is that the simulation associated with it will be with the manufacturer. So for example, when we look at like all the components that we're talking for ADI, they frequently will have those RF simulations and then LT splice models to be able to go through and see like, hey, if I apply power here, how does this change? What am I expecting to get on my outputs? So typically, it's not necessarily going to be that all of the Aero components are done from a simulation perspective, and you could say there's one software for it. But I would recommend that the companies that you work with tend to have some availability for it. That way, when you're doing your designs, you could potentially be able to do a lot of that simulation at home, try some of these components out, see if they're going to react the way that you would expect them to, and then move forward. And again, this is one of the reasons why I would highlight some of what I talked about today with circuits from the lab, is that you have all that simulation available, so you can be able to take and evaluate some of these from just even plugging them into LT Spice, trying some different inputs and seeing how they come out. So not necessarily that we would have a whole Aero library for it, but there are quite a few different simulations available for you if you're working with Aero components.
Awesome. Awesome. Yeah, thank you everyone for the great questions this morning. We're just about at time now. So if you still have any questions, I recommend joining the AIR certification program. It's totally free and you can gain access to an engineering review with an expert at Aero, just like Keaton. To join, just visit our landing page, enterprise.indiegogo.com/Aero, fill out a quick form, and then someone from Aero will be in touch. And we'll be sending out an email with the link and also the recording of this webinar in case you want to rewatch or share with a friend. So just to wrap up, Keaton, thank you so much for hosting and answering all of our questions. And thank you everyone for attending the webinar today. We will see you guys next time.
Thanks, everyone.
Thanks, Keaton. Talk to you soon. Bye, everyone.